Hi, my name is Ritesh Tandon, and I'm a systems engineer with Palo Alto Networks. And I'm not helping customers protect their applications. I'm busy building Gen AI applications which help me work faster and better. In this video, I'm going to build a simple RAG AI chatbot in less than 5 minutes. I will use N8N, which is a low-code, no-code platform, using which you can create simple to advanced automation workflow with just a click of a button and with no prior coding knowledge. So let's begin. The first prerequisite you need is a Docker desktop installed so that you can run N8N. I have already downloaded the N8 Docker image using which I've created a Docker container. When you are creating a Docker container, you also have to map points which will mount with your Windows folder and a path inside the container. This will be used to read your local files which will feed into the RAG pipeline. The second prerequisite is Ollama running on your laptop or even a Ubuntu VM, which I have done. Here I am using a Llama 3.18 billion parameter as the chat model and Noemic embed test as the embedding model for the RAV application we will build. I also have a NVIDIA RTX GPU with CUDA drivers to help with the embedding and inferencing process. We will first start with defining a trigger, which is an execute workflow node. Next, we drag and drop a node to read the files which we want to ingest locally. This is the same mount point which we had defined when we had first created the N8N Docker container. We then connect a node which will extract the text from the files which we had read in the last step. Now this is where it becomes interesting. We will now add a vector database. In my case, I'm using an inbuilt vector store for this demo, but there are many options which you can explore. There are two concepts which you will see here in action. One is chunking and other is embedding. Think of embedding as converting text into a language that computers understand, which is numerical vectors. We'll use Nomic embed text model from Ollama for this. These numerical representations are then stored in vector store and are queried based on their similarity. With chunking, we break down large documents into smaller manageable pieces or chunks using a recursive character text splitter. I chose this splitter because it intelligently tries to keep related text together, respecting paragraphs and sentences, which generally leads to better context for our AI. We are done with phase 1, which is creating the RAG ingestion pipeline. Let's move to the next phase. In phase 2, we create the workflow which caters to the retrieval part in this RAG application. We start with dragging the chat node, which acts as a trigger for the workflow, and we now connect it with the AI agent node. This AI agent node is equipped with the chat model itself, which is Ollama 3.18 billion parameter model, an inbuilt memory node in which we can set the context window for the past interactions, and a tool which is the vector store we used earlier to embed vectors in workflow 1. We will also define the name and description of this tool so that the AI agent knows when to call this tool. This tool then requires our vector store retrieving the most relevant chunks of information we embedded earlier. This retrieved information is then used by our language model to augment its generation. Instead of just guessing, the AI has direct access to your specific documents, allowing it to provide accurate answers while removing hallucination. We are now done with both the workflows. Let's test it out. Let's execute workflow 1. The read-write files from disk node grabs our documents, extract from file node pulls out the text, and the recursive character text splitter intelligently breaks it into chunks. Then Ollama embedding model converts those chunks into numerical embeddings, which are stored in our simple vector store. The best part is you can inspect the outputs of each and every node in N8N's execution logs. We can also see the actual numerical embeddings in the logs. When a user asks a question, the second workflow executes. The AI agent nodes takes over. It intelligently identifies that a tool is needed, which connects it to our vector store. The relevant information is retrieved, combined, and the power of Ollama chat model and a precise answer is generated in real time. This iterative process makes RAG so powerful for accurate context-aware response. I hope this has been useful and thank you for viewing.